Hey guys, so today we are going to move on to part 2 of 7.1, but we want to go ahead and make sure we remember a couple of things from last time. So let's just remember. So we're going to review here. We talked about the sum of interior angles. So if we had a polygon, we talked about what a polygon was, and we said that the sum of the interior angles, this is a formula you want to remember, is 180 times n minus 2. So, for example, if I had a hexagon, I know a hexagon has 6 sides. So I could say that the interior angles of a hexagon would be 180 times 6 minus 2, which is 180 times 4, which equals 720 degrees. So no matter if it's a regular polygon that has the interior angles are all the same, or if it is any type of a hexagon, those angles on the inside will always add up to 720 degrees. The second thing I want to remember, because we are going to talk about it a little bit more today, is that a regular polygon, what that means is that all the sides are the same length and all the angles are the same. So the ones that you probably are most familiar with to start out with is if you had a square. A square has all 4 sides are the same and all the angles are right angles, so they're all the same as well. So a square would be a regular polygon. The other one that we've already talked about is an equilateral triangle. We know that an equilateral triangle has all the sides are the same and all the angles in an equilateral triangle are the same, which is 60 degrees. Okay, so now we are going to start looking at regular polygons, and a regular polygon, just like we just said, means all the sides are the same length and all the angles are the same measure. So here on the left we have a regular pentagon, which means if it's regular, we know that all these sides are the same. So I could say that this side, this side, this side, this side, and this side are all the same. And all of those angles on the inside would be the same measure. So whatever this one is, all the rest of them are also going to be the same. What we are going to figure out that we can do is that we can figure out what each of those angles measures are. Okay, so the first thing we have to figure out is what is the total sum of the interior angles. Okay, so we know we have a pentagon, so we know that it has 5 sides, so we know the sum is going to be 180 times n minus 2. And remember, this is a pentagon, so that means it's going to be 180 times 5 minus 2, which is 180 times 3, which is 540 degrees. So all of them together add up to 540, but I want to know each angle. Well, how many angles are there? There's 1, 2, 3, 4, 5. And if they're all the same, we can just divide by however many angles there are. So we can divide 540 divided by 5 because it's a pentagon. So 540 divided by 5 means that if you had a regular pentagon, each angle on the inside would be 108 degrees. So this one would be 108, this one would be 108, 108, 108, and 108. Okay, so it's nice to have formulas for that. So how can we write a formula to find the measure of each interior angle of a regular polygon? Well, first thing we need to know is the sum of the whole thing. So we need to know what the whole, all of the interior angles are going to equal. So we're going to do what we already know, 180 times n minus 2. That is all the angles. But we're going to divide it by the number of sides or the number of angles that the polygon actually has. So we're going to divide it by the number of sides. So our formula is going to be 180 times n minus 2. That gives us our total. divided by n, which is the number of sides. So let's actually go ahead and practice that. Okay, what is the measure of each, and when you do these, you have to make sure you're reading the question carefully, each interior angle of a regular octagon. Okay, so we have an octagon. We know an octagon means that it has 8 sides, and we know our formula for each interior angle equals the sum, which is all of it, which is 180 times n minus 2, so we'd have 8 minus 2, divided by n, which is 8. So when we put this into our calculator, we want to make sure we follow order of operations. We're going to subtract inside the parentheses first, so we're going to take 180 times 6, and then divide by 8. So make sure you do 180 times 6 first, and then go ahead and divide by 8, and you should get 135 degrees. So if we had an octagon, like a stop sign that you see every day, every angle on the inside is 135 degrees. Okay, so now we're just going to talk a little bit more about quadrilaterals. I'd like you to pause the video for just a second and write down as many types of four-sided shapes that you can think of. And while you're doing that, I will go ahead and write down the ones that I can think of as well, and you can add to your list when you start the video again. So I thought of 6 that I could come up with. I'm sure you hopefully know what a square and a rectangle is. Our next lesson after today is going to be about parallelograms and how we know what a parallelogram is. We'll also later in this chapter get into trapezoids, kites, and rhombuses. But we do know one thing about all quadrilaterals is that if we add the angles on the inside of a quadrilateral, they always add up to 360 degrees because they have 4 sides. So let's use that idea. We've got a quadrilateral here, and we know that if it's a quadrilateral, it adds up to 360 degrees. So we can take and add those angles on the inside, 108 plus 121 plus 59 plus x. So we just added those 4 angles up, and we know since it's a quadrilateral, it should equal 360 degrees. So go ahead and do some algebra here. If we add our like terms together, we get 288 plus x equals 360 degrees. And if we subtract 288 from both sides, we get 72. So this angle, since it's just x, is actually 72 degrees. Okay, so next question goes back to some of the stuff that we did last week. It tells us the sum of the interior angles of this polygon is 1440. 1440 wants us to classify it by how many sides it has. So let's remember our formula for just the interior angles of a polygon. So the interior angles, this isn't each, this is saying all of them together, is 180 times n minus 2. We don't divide by n because we are not finding each interior angle. And it tells us that the sum is 1440. So we know we can say that our sum is 1440 equals 180 times n minus 2. And remember our trick we talked about, if we just divide out 180 first, that makes our life so much easier. So we would say that 1440 divided by 180 is 8 equals n minus 2. So we'd add 2 to both sides and we'd get 10. So we know it has 10 sides, but when it says to classify it, remember we're using those vocabulary words like heptagon, hexagon, pentagon, all of those. So we want to actually use our agon words to describe it. And a 10-sided shape is a decagon. Okay, now we have to read this question carefully. So we have the interior angles. Again, we're talking about the inside. It's a quadrilateral, so we know it has 4 sides. It also means it has 4 angles. Okay, our x, 3x, 5x, and 7x. Let's just find x in this case. Okay, so we'll go ahead and just find, rather than finding all of the angles, we'll just find x. Well, we know if it has 4 sides, all of those angles have to add up to 360 degrees. So we know that those 4 angles are x plus 3x plus 5x plus 7x. All those are going to be, since they're all in a quadrilateral, they add up to 360. When we combine our like terms, we get 16x equals 360. And if we divide by 16, we're going to have to round just a little bit, and we would get 22.5 degrees. Okay, so now we are going to shift our brains a little bit. If you notice in this picture, we are no longer talking about the angles on the inside. These angles here are on the inside. We're now looking at the angles that are on the outside, which are our exterior angles. Okay, so now we're looking at these angles on the outside. And the nice part about exterior angles is no matter how many sides the polygon has, the exterior angles always, always, always add up to 360 degrees. Doesn't matter how many sides are on that polygon. If you go on the outside of it all the way around, you add up to 360 degrees. So that's nice and easy. You always know what the angle sum is. But if it is a regular polygon, okay, so if we want to know what each exterior angle is of a regular polygon, we are going to take all of them together, which remember, if it's the exterior angles, it always adds up to 360. And we are just going to divide by however many sides it is. So again, these are always making sure when you read the questions, read them carefully and ask yourself, are they asking about interior angles or exterior angles? And are they asking if it's a sum of the whole thing or if it is actually asking for each angle? So read your questions carefully. Okay, so looking at my diagram, I'm going to find the value of x. And I notice, first of all, that the angles are on the outside. Okay, all my angles are on the exterior of my polygon, which means all of those are always going to add up to equal 360 degrees. And it's obviously not a regular polygon because all the sides are different lengths, which means it is not going to be dividing by anything. We're not finding each angle because it tells us what each angle is. We're just adding them all and figuring out how to find x. So we're going to say 2x. If I add 2x plus x plus 67 plus 89, if I add all of my exterior angles up, it's going to equal 360. This is exterior angles is always going to be 360. So let's go ahead and combine our like terms, and I would get 2x plus x is 3x. If I add 67 and 89, I get 156. And then I just go ahead and simplify here, or solve my equation. I'm going to subtract 156 from both sides. And I get 204. And if I divide out 3, I get that x equals 68. Exterior angles are a little bit easier just because they are always going to add up to equal 360, not like the interior angles that can add up to different values each time. Okay, so now we're going to have to look at our picture. There's a lot of things we have to make sure we know. And it says we have this trampoline. It's shaped like a dodecagon, which has 12 sides. So we know that n equals 12. Our first question asks us to find each interior angle. Okay, so let's think back. If we have interior angles, that means we have to find the sum of all of them. That's our 180 times n minus 2. But since it's asking about each of them, that means we have to divide by the number of sides. So now I know that each interior angle, okay, I know that n equals 12 because it's a dodecagon. It says it has 12 sides. So I'm going to say 180 times 12 minus 2 divided by how many sides did it have? It had 12. Again, I'm going to subtract inside my parentheses and do 180 times 10, which is 1800, and then 1800 divided by 12 is 150. So we would have 180 times 10 divided by 12, and we would end up at 150 degrees. So each of these angles inside of here is 150 degrees. On the second one, it's asking about exterior angles. Okay, so now we're talking about the angles on the outside, and so we know that exterior angles, so each exterior angle we know that all of them together always add up to 360, and we're going to divide that by however many angles there are. In this case, since n is 12, we're going to divide by 12. So each exterior angle is going to be 30 degrees, 360 divided by 12. Okay, this last slide is a good one to keep out when you go to do your homework and things like that, because it has all the formulas you need. So we've got, first of all, to find the sum of the interior angles of the polygon, what formula do we use? Okay, so we're talking just the interior angles, not each interior angle. All the interior angles together. Our formula, okay, and I always like to write it as an equation, not just 180 times n minus 2, so I know what I'm finding. I'm finding the sum of the interior angles equals 180 times n minus 2. So that's our first formula we use if we're finding the sum of all of the angles. The second question says if it's a regular polygon, the measure of each, oopsies, interior angle, let's highlight that instead. Measure of each interior angle means we are going to take the sum of all of them and divide it by however many sides there are. So we would say that each interior angle equals, okay, so we're just going to take what we have up here, our whole sum, which is 180 times n minus 2, and divide it by the number of sides. Now, in the next one, it's looking at exterior angles. Oops. Choose a different color here. So now we're talking exterior angles, and if you're talking exterior angles, we know they always add up to 360 degrees. If it's a regular polygon, each exterior angle means we take that 360 degrees. So we'd say each exterior angle equals 360, which is the total, divided by however many sides the polygon has. And for your homework this evening, I would like for you to do your Big Ideas homework assignment. Most of you already finished 7.1 part 1. This is going to be 7.1 part 2.